Okay, my name is Marco Mancini, and I will give a talk about some services that we provision at CMCC, and I will give a brief summary of some of the projects where we deliver, we provision this kind of services for data analytics and HPC. Just few words about the CMCC. Is a Euro-Mediterranean Center on Climate Change, and is a non-profit research institution composed of several institutions like ENGV, the National Institution for Earthquake and Volcanology, and then there is CIRA and University Ca' Foscari from Venezia, and Unisalento from Lecce, and other associate centers, University from Sassari. The organization is at the moment with 8 divisions, and each division has its own research field. And for example, ocean modeling, data assimilation, ocean prediction, climate simulation. The objective of the CMCC is to do research on climate change and to promote scientific activities in this field. And it was born in 2005 from fundings from Ministry of Education and Research in Italy. And also there is a division, the Advanced Scientific Computing Division, that provides tools like data management, so big data analytics, and also optimization and HPC codes. When I sent this contribution, I was in this division, but recently I joined the Supercomputing Center, so now I am this one, it's the same. Yeah, I am in Gallipoli, it's a nice city in Salento, and I joined the Supercomputing Center recently. So I did research on cloud for data management and HPC. Now I'm trying to push these technologies at the data center level in order to improve services from the data center. So this is the group of the people that works at the Supercomputing Center. So I will give a brief introduction of the HPC infrastructure and architecture that we have at the data center. Then I will speak about the cloud, the private cloud deployment that we did at CMCC with OpenNebula, and I will speak about some services for data analytics and HPC that we used in these projects, and I will tell something about the projects. Okay, this is the supercomputer that we have at CMCC. His name is Athena, and it's an IBM system with iDataplex. It's about 7,700 cores, and based on Xeon Sandy Bridge. So the connection is based on InfiniBand, 40 gigabit per second. The storage is based on DDN, with about 840 terabyte storage. And then we have a system for the backup and the hierarchical storage management based on a tape library from IBM. This is the HPC system. And now I will give instead this is the deployment of the private cloud. We have 3 clusters. One cluster is 3 servers that is used for, let's say, light VM or service cluster. So if you want to put, for example, the Rados gateway from Ceph, we will put here. And these are just for, let's say, for services, or let's say a web server, or for example, I will show we have some services based on delivering NetCDF files. So in that case, it's similar to a web server, so we will put on this kind of cluster. Then we have another cluster with the 6 server, and that we use for a framework that does data analytics, and it has 256 gigabyte RAM per node. And we used also this 6 node to provide the safe storage for the VM. So we did, we kind of isolated the process of safe by using C groups, and also by using the pinning for this process, and then we reserved this kind of CPU from OpenNebula. And then we used 10 nodes from Athena, and we built a cluster, a small cluster, for HPC, and this cluster has 4 gigabit InfiniBand network interconnection, and is interfaced also with the storage that from DDN, and we use the file system. I forgot it. The file system that we use is a GPFS for the HPC facilities. As a storage for these 2 clusters, instead we use Ceph. We have 3 monitors, 24 OSD, and this provide like 70 terabyte storage raw. Okay, the front end to manage this cluster where there are hypervisor KVM is OpenNebula, and we have deployed OpenNebula front end in H availability mode. We had some issue with just PCS and install gems, but what we did is to separate 1D, the Sunstone, and the MySQL. We have different layers, and then we use also HA proxy for the before the front end, before the Sunstone, and also we used PCS, pacemaker recursing for the HA proxy. So this has been done in a H availability mode, and okay. Okay, this is the architecture of the data analytics framework that has been developed at CMCC. The name is Ophidia. You can have information about this data analytics framework at ophidia.cmcc.it. And this has been developed by the Advanced Scientific Computing Division at CMCC. And the objective is to deal with scientific data. Is not for like Hadoop for logs data or some, but the design has been tailored to scientific data, multi-dimensional data. In particular, at level of storage, there is a storage model that is based on partitioning, on clever partitioning of data, and so in this kind of partitioning is exploited at the level of the I/O nodes. That is another component where the analysis is done by using a parallel access to the storage, because a multidimensional cube, a data cube, is partitioned on the storage, and then all the analytics and the operation has been executed at the level of the I/O nodes. That can be several I/O nodes, and most of the operators are array-based primitives, so it's based on array. Then there is the part of the compute nodes that are related to the operators, so subsetting, importing a dataset, exporting a dataset, slicing, whatever operator you can think of on multidimensional data or scientific computing data. You can there are a lot of operators. If you look at the website, there are, I don't know the number now, but there are several operators that have been implemented. And then there is the Ophidia server that does they provide several interfaces to, for example, to a client, and has been implemented also the terminal, a terminal like a shell that can be used to provide operation on data set. So this is about the framework, and regarding the HPC, what we have been done is to virtualize the InfiniBand with SRIOV. So we did some, the Athena is a bit old because it's 2012 deploy. So we had to update some the firmware, and then we installed recently the driver from Mellanox, more recent driver. And we use an add-on that is provided for OpenNebula, is KVM SRIOV, that has been written by David McLeod, I think, someone from High Performance Center, I don't remember now. And then we enabled also the HPC by pinning the CPU and by using the huge page. Okay, the services for HPC that we would like to do is not for batch jobs, but for example for productional environments. Usually at CMCC we have batch jobs that are related to simulation of climate scenarios, ocean forecasting and so on. But then we have what they so-called operational chains that usually are related to services. So are like products, services that have to run. And we think that having customized insulated environments for the operational chain could be very interesting. That's what we are trying to do with this kind of HPC service. In particular, what we would like to do is to test this service on some of the software that are used, that are model simulation, like NEMO, that is a software for the simulation of an ocean that is developed in Europe by Mercator, but also by CMCC and GVU's several institutions have developed in this software in Europe. And WRF is the weather forecasting model, and also SciFem is unstructured also for the ocean. What is okay? Regarding the provisioning, at the moment we have used this tool that is called the Infrastructure Manager. We are in a project with the Universidad Politecnica de Valencia, that is EUBrazil, that I will give some. And this Infrastructure Manager gives the possibility to configure and to configure when you deploy the machine, the virtual machine, you can configure, and it uses Ansible. For example, you can write a role, an Ansible role, and then you can use this Ansible role inside the Infrastructure Manager in order to configure a VM that is being deployed on OpenNebula, for example. This tool is agnostic. It doesn't depend on the cloud provider, but we have used for provisioning and for orchestrating some of the services. So just a few words about the three projects. We have, there is this one is EUBrazil, as I said before, where we are in collaboration also with the Universidad Politecnica de Valencia, and where we use also this the Infrastructure Manager tool. And is a research project between European and Brazilian communities, research communities, is to test the execution of scientific application on heterogeneous infrastructures. And so there are private clouds, supercomputing facilities, and so on. The other project is called Ophidia, but it's with the F, not PH, so it's another. And this is instead is to build a cross-border operational fire danger prevention infrastructure. and to detect and fight forest wildfires. Copernicus instead is a project from the European Union, and this is more is a service that is provided by Mercator. Then they make tenders, they give grants, and the CMCC has got a grant for providing ocean forecasting and other products. Okay. Very quickly, what we did is for the big data analytics, we deploy several scenarios so that, for example, we can deploy Ophidia as a standalone instance, as a standalone VM instance, or we can deploy, because as I said to you before, there is the server component, I/O components, and compute components. So it depends how we split these components in different VM. We can scale the compute nodes, we can scale the I/O nodes, or we just, if you want just a standalone for testing or small workload, we just deploy as a small instance, okay? So these are the three scenarios, and we have used the infrastructure manager and some Ansible roles that configure the VM once they are deployed on OpenNebula, okay? The other one instead is related to Ophidia. This is the Ophidia in a snapshot, and we have a wireless sensor network that we have deployed in Apulia in 6 wooded area. And there are also 2 weather stations that we have deployed in the project. And there are also, this is in INTERREG with Greece, so we have also the Greek partner that provides data from their wireless sensor networks and their weather station. And what we have done, we have deployed, also in this case, a data analytics platform based on Ophidia. And this platform takes as input the data from the WRF, weather forecasting model, and produce maps at the end for the stakeholders that are fire index maps and also weather maps. And these maps have been are deployed daily, and at the moment we have every day we can deploy 3 days forecasting, and so you can have a map, a risk map for that 3 days. So this could be like a decision support tool for protection of the wooded area, okay? And so in this case, we have used, again, the infrastructure manager. We have deployed these services on our private cloud. And, okay. I think I have 2 minutes. Okay. The last one is instead Copernicus. This is okay, this is a work in progress. I mean, we are just started the tender, the grant, and we decided also to use the cloud for delivering this service. In particular, the architecture is, there are several partners also here, and there are, each partner is responsible for some unit. The production unit is the unit that produce data, so like Mediterranean forecasting or the waves forecasting, currents, temperature, and so on. There is also biogeochemistry, a production unit. And the dissemination unit, archive unit are the responsible for the delivery of the products. So the idea is to have the main unit and also some backup for the unit in order to have, because we have a target and a service level agreement with Mercator, so we have to respect this target, okay? And so what we are evaluating, and we are going to do is to to the backup of the dissemination unit by using our private cloud with the public cloud. And because maybe it's more available Amazon or Microsoft or Google than our data center. And the idea, so it's very simple. I mean, we will have the services that most of the time will be delivered by the CMCC, and in particular we are considering to put the files in a S3 service in order to synchronize with the S3 service that could be provided, for example, from Amazon or maybe some other object store provided by another public cloud. And then we have two modules that are important. One is the NH availability DNS that will switch between the two sites. It depends especially if CMCC can go down or if there is a maintenance in some day for the connection or whatever. And there is a module that has to sync, that is in charge for take in consistency the two sites, because the point is that in Copernicus we have two kinds of activities. One is the download of the products, and that is okay. I mean, if we have the file they are syncing, then there is a copy, is okay. The point is when there is an upload, so it's going to change the file system. If the uploads happen when the CMCC is down, we have to take in account this activity in order to sync again the two sites. So this is a simple idea in order to get the service. I discussed with some guy. They said maybe a cost-effective could be to rent some server and then to deploy, for example, OpenNebula on another data center that we can build from an hardware provider. I think that the work in progress, okay, I said that we are using infrastructure manager, but I really like OneFlow, OneGate. I'm working with it, and I'm using Ansible for the configuration. So I wrote a dynamic host list. It's a script that gets the VM and the configuration of the VM from OneFlow, and then I pass this as a dynamic inventory to an Ansible script. The only thing is that I don't know when to start this script, because at the moment the hooks in OpenNebula are related to VM, but are not related to service. So I don't know when the service has created all the VM. So that's one point that also already said during the first day at the Hacking Essential could be interesting if we can some way introduce also hooks for the OneFlow services in order to have an idea in which state is the service. The point is how to define the state of the service. And then I've seen also the other project, Panacea, the project, and I'm looking at the OneGate and the functionality for elasticity, especially for the Ophidia framework, where we can then balance the cluster according to the number of files, to the number of activity that we have at level of big data analytics. The last one is, my intention is to virtualize Athena with OpenNebula. Okay. This is just for this, I mean, if we want to talk about HPC in cloud, real HPC in cloud, we need other, okay, I did some tests with KVM with huge page spinning, it's going good. I mean, the overhead was, I think, less than 1%. The problem is the SRIOV. We had some problems in scalability. So in order to solve this problem, real HPC in class, and then it's also how to solve, for example, the problem of virtualization of InfiniBand. And that's all. Okay, thank you.